Finding sector area is a similar process to finding arc length, except instead of finding a fraction of the circumference, we find a fraction of the area of a circle. The area of a circle is found by calculating pi r squared. R is the length of the radius. Area is always measured in square units. And a sector is a slice of a circle, which basically makes it look like a slice of pie. The area of a sector can be found in a similar fashion to arc length. The ratio of the arc measure to the whole circle is equal to the ratio of the sector area to the area of the entire circle. So we can use a proportion, or we can use a rearranged version of the proportion that solves for area of the sector directly by finding a fraction of the area of the circle. Let's try some examples. Find the area of the shaded region. Well, I can see that the central angle is a right angle, which means it has a measure of 90 degrees. The arc measure is also 90 degrees. So I know I'm talking about a fraction of the circle, 90 degrees, out of the entire 360 degrees. And if I want to find sector area, I need to find a fraction of the circle's area. So let's find the area of the circle. Area equals pi times the radius squared. 36 pi centimeters squared is the area of the circle. We can reduce the fraction. The fraction of the circle is 1/4 of the circle. The entire area of the circle is 36 pi. So our exact area of the sector is 9 pi centimeters squared. Next example. Now we're working a little backwards, finding the area of the circle. This might be when we want to use the proportion so that we can cross multiply and divide and solve for what we are looking for. Again, in this case, the area of the circle. I can see the fractional part of the circle is 80 degrees out of 360. That would be equal to the area of the sector, which has been given, out of the area of the entire circle. All we need to do is cross multiply. (24 times 360). And divide by 80. The area of the circle is 108 feet squared. And we didn't actually even have to round to 2 decimal places. It came out exactly. One more example. Lots of parts. Starting with, for the circle shown, determine the measure of arc FGE. at is this arc measure, which would be the entire circle less 51 degrees, or 309 degrees. Arc measure is in degrees. Now we can use that to determine the radius of the circle. I know the fractional part of my circle is 309 out of 360. I know that the area of the shaded sector is 31 out of the entire area of the circle. We can cross multiply and divide. So go ahead and multiply 31 times 360, divide by 309. And we will get 31 times 360 divided by 309, 36.1165. I'm going to keep some extra decimal places for rounding error in my next step, because my next step asked me to find the radius of the circle. So I need to keep going. Area, I know the area of the circle. Area is pi r squared. I will divide both sides by pi. And take the square root. And we were measuring in meters. That's the length of the radius. And by keeping several extra decimal places throughout my calculation, I avoided any kind of large rounding error. Finally, question C asks us to find the diameter of the circle. And we know that the diameter is equal to 2 times the radius. So I double the length of my radius, and the diameter is 6.78 meters.